You've seen how to count and measure things with rational numbers. You've also seen how to graph rational numbers on a number line and find absolute value. In this video, we develop techniques for subtracting rational numbers. Let's start with an example. With this thermometer, each tick mark represents a change of half a degree Fahrenheit. The two temperatures that are highlighted are the low and high temperatures for the day. What is the temperature range for this day? Turn the thermometer into a horizontal number line and label the points on the number line. The low is -1, -2, -3 degrees Fahrenheit. The high is 1, 2, 3.5 degrees Fahrenheit. To find the range of values, subtract these two numbers. Subtracting a negative is the same as adding a positive. The result is 6.5. Let's look at another example. With this thermometer, each tick mark represents a change of 0.5 degrees Fahrenheit. What is the change in temperature in going from A to B? What about in going from B to A? Turn the thermometer into a horizontal number line and label the numbers on the number line. The expression A minus B is shown here. Subtracting a negative is the same as adding a positive. The result is 3. The expression B minus A is shown here. Subtracting a negative is the same as adding a positive. The result is -3. Note that the difference in going from A to B is positive, while the difference in going from B to A is negative, but the absolute values are the same. Let's look at another example. This series of images over a 3-second period shows the movement of a fish and bird. What's the vertical distance between the two at the start? Each tick mark represents 0.25 feet. To the nearest quarter of a foot, the initial vertical position of the fish and the bird are shown on this vertical number line. For the fish, the distance is -1, 2 fourths, -2 fourths, or -1/2. For the bird, the distance is 1, 2, 3, 4, 5, 6, 7 fourths. The distance between the bird and the fish is shown here. The subtraction changes to addition. We find a common denominator of 4. The difference is 9 fourths. Written as a mixed number, we get 2 1/4. Let's look at another example. Two rational numbers on a number line are equally far apart from 0. One number is negative and one number is positive. What is their difference? The letters shown on the number line represent rational numbers that are the same distance from 0. So the absolute value for each number is the same as shown here. The difference between A and -A is shown here. Recall that subtracting a negative is the same as adding a positive. We get A plus A, which is 2A. Why did we choose a letter to represent a rational number rather than specific numbers? What we have shown are several things. First, every non-zero rational number has an opposite. Second, rational numbers and their opposites have the same absolute value and are the same distance from 0 on the number line. The distance between the two opposites is twice the absolute value of either number.